Okay guys, we're going to talk about the second chemometric way to analyze something. Gravimetric analysis. It's a fancy word for let's precipitate it out and weigh it. Okay? So we choose a precipitation reaction and then turn that particular analyte into a solid precipitate. And then we filter it and then we dry it and we finally weigh it, okay? And then we do the calculations to express it in a percentage weight for weight concentration. It's most commonly taught and used for some very common problems in past HSCs is determining the sulfate content of lawn fertilizers, okay? Firstly, what you do is you homogenize your mixture and then take a representative sample, okay? If you don't homogenize it, you're not going to get a representative sample. You're going to get, say, like gravity, settling of certain components and lighter bits up top. So you need a homogenize and then random sample. And then you're going to dissolve that in water. And then to precipitate out the sulfate, we're going to add in barium nitrate. So barium nitrate will deliver barium ions in solution. So then when they meet the sulfate, they precipitate out, okay? And so we're going to get that white barium persulfate or just barium sulfate precipitate, okay? And then we're going to filter that using a setup like this with a funnel with a paper in, and we're going to first dry that sample to get rid of any water. We don't want to presume that the water is the content, so we're going to dry it out and then we're going to weigh it. Here's a graphical way that I stole from what's his name? Cole Harrison. Good videos. So, weigh the sample to be analysed. So you get the initial mass, dissolve it in water, add something to form a precipitate. So for the sulfate, we're going to add barium in there. So barium nitrate will be nice soluble barium salt. And then we're going to filter and collect, and then we're going to dry and weigh. Okay? Alright, so let's do a practice problem. A 2.45 gram sample of lawn fertilizer was analysed for its sulfate content. After filtration and drying, 2.18 grams of barium sulfate were recovered. Okay, what is the percentage weight for sulfate of the lawn fertilizer? Okay, so we've got 2.18 grams of barium sulfate. Okay, and we want to know what mass is just sulfate. Okay, so there's several ways that we can do this, but I think the best is just to go to how many moles of barium sulfate do we have. So 2.18 grams divided by barium mass is 137.33 grams per mole. How embarrassing. 137.33, and we've got one sulfur, which is 32.07 grams per mole, and 4 oxygens, and they're each 16.00 grams per mole. Okay, so we're going to get moles as our unit left over, because the grams are going to cancel. Moles are going to come to the top. Alright, let me calculate. 2.18 divided by bracket 137.33 plus my sulfur, which is 32.07, plus my 4 oxygens, which is 16, and bracket, and I get 9.34 times 10 to the negative 3 moles. Okay. If I have that many moles of barium sulfate, I must therefore have 9.34 times 10 to the negative 3 moles of sulfate. Okay, so mass of sulfate is going to equal 9.34 times 10 to the negative 3 molar sulfate times the molar mass of sulfate. 32.07 plus 4 times 16. I'm sure those mathematical people out there are going, couldn't you just do it like this? Yes, you can, of course, but I'm taking the plotting way. Okay, so multiply my answer by 32.07 plus 4 times 16. So I get 0.89371 grams. Okay, so that's the mass of sulfate in the sample. So the mass percentage, wait, equals 0.89371 grams over the original sample was 2.45 grams times it by 100%. Oh, not 10%, 100%. Put in my calculator, 2.45 times it by 100, and I get, look at those three sig figs in the answer, so I get 36.6%. So I get answer B there. Excuse me. Okay, let's do another practice one, and that'll be the end. Flowchart. Shown the outlines of the process to determine the amount of sulfate in a sample. So, weigh. Step 1 is dissolve, filtered, and rinse. So we get the filtrate, and anything that's not dissolved we get rid of. So our sulfate will be in solution here. Then we add our barium 2+, and we get a precipitate. Then we filter that out. We don't care about the filtrate. We care about the filter. We rinse it and dry and weigh that at the end. That's a really good flowchart, actually. Good possibility that you could have this question another way around. Draw a flowchart for the process of gravimetric analysis of sulfate in lawn fertilizer. What assumptions were we made, and how do these affect the validity of the process? This is a good one, okay? What assumptions are we making? Okay, we're going to dissolve, filter, and rinse first. So we're assuming that all of the sulfate salts are soluble. So we're assuming all sulfate is initially soluble. Okay? So that's in the step 1, we're assuming all the sulfates are soluble, but we know not all of them are. Let's do a quick search, but we know that barium is not. So let's look up I probably should know this offhand, but sulfate solubility. Probably silver and stuff like that. I can't really see them being in fertilizer. Oh, I'm not really getting a good one there. But anyway, most sulfates are soluble. But not all of them. So that's one assumption. Okay, and then we're going to add the barium to that solution. And we're going to presume that everything that precipitates out is barium sulfate. Okay? What about other barium salts that are not soluble? Okay, we're going to precipitate out other salts, maybe too. Okay, and are they present in the fertilizer? So we've made that assumption too. Okay, so 2 assumptions: all sulfate is soluble, and all precipitate are barium sulfate. There's the 2 assumptions for the validity of this. It was found that 4.25 grams had a sulfate content of 35%. Am I writing this? Have I got that right? Yep. Okay. What is the mass of the dried precipitate at step 4? This is backwards. I like this one. Okay. If it's 35%, 0.35 equals some precipitate mass, some mass of sulfate divided by 4.25 grams. Okay, so multiply it out and we get our mass of sulfate present is 0.35 times 4.25, so 1.4875 grams. 1.4875 grams is sulfate. Include a chemical equation. Alright. Barium 2 plus sulfate 2 minus goes to barium sulfate. Oh, I don't need the 2 minus there. What am I doing? Oh, what a duffer. Okay, so there's your chemical equation. So we've got 1.4875 grams of sulfate. So how many moles of sulfate? So it equals that divided by 32.07 plus 4 times 16. So I get, where am I going? 0.015488 moles of sulfate. So I'm going to have the same amount of moles of barium sulfate because it's a 1-to-1 here. And so that is going to weigh times it by the molar mass of barium sulfate. Sorry, just doing it in my head. Doesn't work well on video. So multiply it by the molar mass of barium sulfate, which is 137.33 plus the 32.07 plus the 4 times 16. So the mass of barium sulfate was 3.61 grams. Okay, so the mass of the precipitate that formed, 3.61 grams. All right. You can now do these questions, and there's a worked example from the textbook as well, and some check your understanding problems from the textbook. Let's call it quits there.